This is Algebra 1A, Day 24, Lesson 15 in Unit 3, writing equations, this time given a point and a parallel or a perpendicular line. So by the end of this lesson, you should be able to say with confidence that you can find the slope from a parallel line, find the slope from a perpendicular line, or from a perpendicular line, and then write it in an equation in slope-intercept form, given one point and either that point, that parallel or perpendicular line. On this page you see we have equations of two different lines. If we were to graph them both on the same coordinate plane, what would you notice about them? Well, let's graph one. I'm going to use purple to graph this line right here. Alright, I will start with the y-intercept of 4. And I will use the slope to find the next point in the line. So I'll go up 1 over 2. There's the next point on that line. And then I'm going to connect the dots there. Make a straight line as possible. Alright, let me change my pen colors here for you. And now I'm going to graph the second line. I'll start at the y-intercept of -2, plot that point, use my slope to find the next point, so I go up 1 over 2, and then I connect the dots with a straight line. Alright, what do we notice about these two lines? Think about that for a second. We'll compare it to the next two. Alright, it won't let me scroll down. So can you identify, what do we call it when we have two lines that are equal distance apart all the way down the line and never intersect? Do you remember what that's called? Parallel. Those are parallel lines. Compare those two equations we just graphed. How are they similar and how are they different? Do you notice that the slopes of both of those equations are the same? But the y-intercepts are different. Whenever you have two equations with the exact same slope, they will always form parallel lines unless the y-intercepts are also the same. So as long as the y-intercepts are different but your slopes are the same, you will always create parallel lines. Alright, let's take another example at two other equations. I'm going to graph this top equation in blue. I'll start at the y-intercept again of +3. Use the slope, which is -4. So how would you write that as a slope so that we can graph it? -4 over 1. So you go down 4 because it's negative. 1, 2, 3, 4. That takes us down to -1. And over to the right 3, or run right 3. And there's your second point. Let's graph that line. Oops. Try that again. Alright, and I'm going to graph the second line in purple here. So go to my y-intercept of -1. I go up 1 over 4. And then connect the dots with the line. Let me see if I graph that as straight as I possibly can. Let me check this again. Okay, maybe you caught my mistake. I regraphed that first equation. We start at +3 and then just go down 4 over 1. So down 4 over 1 should take you right about here. And then the other line, start at -1 and you're going up 1 over 4. So that one is right here. There we go. Now we're getting the line I was expecting to see. That other one looked funny. So notice our equations. What's different about them? Well, it looks like at first glance maybe everything's different. But take a look at their slopes. In the previous example, our slopes were identical. Here are slopes. Notice the number's the same, but we have an opposite sign, and it looks like it may be revert or flipped. It really is. In our first equation, the slope of the line is -4, or -4/1. In the second equation, if we were to flip that fraction around, put it 1/4 and keep it positive, this is called its opposite inverse. Opposite inverse. Which basically means we flip the fraction and change the sign. When you notice that the slopes are opposite inverses of each other, they will always create perpendicular lines. Perpendicular. Oops, ran out of room here. Hold on. Perpendicular AR. There we go. That's supposed to be an L. ULAR. There we go. And what that means is those two lines are intersecting at 90 degrees. All right, let's see what that can do for us when we're trying to write an equation of a line in slope-intercept form that is perpendicular or parallel to another line. But first, we're also going to learn another vocabulary word. Circle the product of a number and its reciprocal. A reciprocal simply means that it is the opposite sign. So you can clearly see if we have 1, the opposite sign is -1. That's its reciprocal. Circle the pair of numbers that are reciprocals. Well, these two are reciprocals. And so opposite and inverse of each other. That opposite and inverse means that it's reciprocal. So if we flip the fraction around, that 1, that positive 1 we see is positive 1/1. If we were to flip it, we still have 1/1, and then you change its sign. So that's how we got the -1. So 1 and -1 are reciprocals of one another. In this row, is there any more? Sure. -3/4 and -4/3. So if your slopes are reciprocals, or opposite inverses, then you always create a perpendicular line. And again, the new vocabulary that I'm using here is the word parallel, and a related word is perpendicular. So in math, lines that are parallel are lines in the same plane that never intersect. The symbol for parallel is two straight lines up and down. So using the symbols, you see that it says line AB is parallel to line CD, means that AB is parallel to CD, okay? The stripes in the American flag are parallel. It doesn't matter if they're going up and down, or if they're vertical, or if they're horizontal, or if they're diagonal. If they never intersect, then they're parallel lines. So let's look in this picture here. For each image underneath, use your vocabulary. In the sentence that says, like, the railroad tracks in picture A are, you could write the words parallel or perpendicular, or you can use their symbols. As I showed you before, two vertical lines mean parallel. The symbol for perpendicular line is two lines that are actually perpendicular. They look like an upside down T. So the railroad tracks in picture A are parallel. The window bars in picture B that do not meet are also parallel. They're referring to the straight up and down ones. But the roads in picture C are perpendicular. Pretty easy. And then finally, just a quick review of the different forms of a line. You have the slope-intercept form. That's when you have the equation y equals mx plus b, where m represents the slope and b represents the y-intercept. Standard form, that's when your x and y term come before the equal sign and always equals a constant. And finally, point-slope form. And this is the one we haven't used very much. That's where you use the point-slope formula. Y opposite of y1 is equal to the slope times the quantity of x minus x1. This form, you'll always see that set of parentheses. So you know you're not working with point-slope form unless you see parentheses. where x1 and y1 represent a point on the slope, and m represents the slope. So let's take a closer look again at point-slope form of a linear equation. If you have an equation in point-slope form, what do the x1 and y represent? Well, they represent just a single point on the line. What does m represent? Well, it represents the same thing in any equation. When you see the letter m, it is the slope. In our key concepts of slopes of parallel lines, I said before that the slopes of parallel lines are the same. So here we have three equations. I'm going to go ahead and number them 1, 2, and 3 here for you. And another set of equations, we'll call them A, B, and C for now. And the directions say to draw a line from one column to the other whose lines are parallel. Well, if they're parallel, then that means they have to have the same slope. So let's see if we can do that. On your first equation, number 1, which letter will that go to? Well, if our slope is 2, B is the only one with a slope of 2. In equation 2, the slope is 1/3, so you would draw it to the equation C, because it also has a slope of 1/3. And finally, of course, that leaves number 3. You would draw your line to A, because the slopes are the same. Now you're looking at that and like, wait a minute, why is my x over there? I don't see any numbers here. If you were to take x to the other side of the equation, it would be a -1. -1. It's a +1 where it's at, but its x is equal to a number. Remember, when you do not have a y variable in an equation, what is that an equation of? It's a line that's going straight up and down and vertical. If whatever number they're equal to are not the same, then you will always have parallel lines. Alright, I'm going to be demonstrating how to solve each one of these problems for an equation that's in slope-intercept form using two different methods. One of the methods we've already done before, where we just take the slope-intercept form of an equation, we plug in our mx and b value or whatever from the point, or your x, y, and m values, into the equation. And then I'm going to also show you how you can do this from the point slope form of an equation. You'll probably find one of them much easier to use than the other. Everyone has their own preference on this, so I'm going to let you decide which you would prefer. I have mine own, but I want you to make up your own minds of which one you prefer. When you're given a parallel or a perpendicular line, the only thing that you care about or are concerned about is what the slope is of that parallel or perpendicular line. The whole rest of the equation is irrelevant. So what is the slope of our parallel line? Well, parallel line is -4. So what does that tell us about the point of the equation that we're trying, or the equation we're trying to write? We know our line that we want to write is parallel to our red line. Well, we know then the slopes have to be the same. That's what parallel means. The slopes are the same. So our final equation, y is equal to mx plus b, will be, we have part of it already finished off. We know what the slope is of our new line. Now we need to figure out what b is equal to. We've done this before, so ignore the steps over there to the left for a moment, because we've done this before. When we have the y equals mx plus b equation, we can plug in our givens, the slope, -4, the x value, which is 2, and our y value, -5, and then we just had to solve for b. We did that by multiplying our m and x together to get -8, and we brought that -8 to the other side of the equation as +8. After we combined our like terms, we see that we got a 3. We found out that b is equal to 3, and that b value is our y-intercept of our equation, and we're done. Okay, so that should look pretty familiar to you at this point. If it doesn't, then you need to go back and practice those types of problems again. Now I'm going to show you how you can also solve this using the point-slope form of an equation. point-slope form is y is equal to the y value that you're given, I'm sorry, not equal to, minus, or the opposite of. There we go. So y, opposite of the y value that you're given, is equal to the slope times x minus, or the opposite of, the x value you are given. So when you use this point-slope form of an equation, it's expecting that you have been given one point, an x and y value, and a slope. Well, that's what we have been given. We've been given a slope and an x and y value. The tricky part of this, using this formula, is that notice where the x and y are. We have our y on the left-hand side and our x on the right-hand side. Well, when you're given a point, here's our x value and here's our y value. So to help you remember how this equation works, notice that the equation says the opposite of. That's that negative sign. If you say minus this, then what it's going to do is always reverse the sign. It's sort of like this. I need to move my 2 value, my 2 to the opposite side of the equation. What do I do in it? I change its sign, so negative 2. So that whole value becomes negative 2. If I bring this negative 5 to the other side of the equation, this all becomes positive 5. So y plus 5 is equal to, and we've been given our slope, negative 4, times the quantity x minus 2. So you're just reversing the signs. And then you use your derivative property. So y plus 5 is equal to negative 4x. Negative times the positive is positive 8. You're trying to get that y all by itself. So you bring that over as a negative 5. So your equation is y is equal to negative 4x plus 3. And that's what we were trying to get to, is that slope-intercept form of a line. So we're done. Now, this might look more complicated to you because you've done it the other way and it's more familiar to you the other way. But just reversing it, and then you only have to move one term. I know, like I said, everybody makes their own opinions about this. Sometimes it always is the method they learn first is what they prefer. I'll show you another example, but this time I'm going to start off using the point-slope form equation. So point-slope form is y opposite of y1, and that means the opposite of our point that we're given, is equal to the slope times the quantity x minus the x point that you're given. So let's look for our givens. We're given an x, a y value, and a slope. Because it does say parallel, we use the same slope. What is that slope? I see a negative x there. So what's that slope? The slope is equal to negative 1. Alright, plug it into the equation. So y opposite of our y point. Well, our y point is 3, so we write minus 3. It's equal to the slope, you see that is negative 1, times the quantity x, and then opposite of our x point. Our x coordinate is negative 1, so we would write plus 1. That's its opposite. Then you're just simplifying this and keeping it and solving for y. So we multiply our m inside the parentheses. So you get y minus 3 is equal to negative 1x, or just negative x. And then negative 1 times a positive 1, that is a multiplication, so that would be a negative 1. Be careful, I see a lot of people put 0 here. Remember that when you're using that distributive property, you are multiplying, not combining. We're still trying to get y all by itself, so we have to add 3 to both sides so that that will cancel out, and y is equal to then negative x plus 2. So you can see it's really not that bad. The hardest part is remembering this formula right here, which I believe on the ECA is given to you, so you don't have to memorize that formula. And so that's really not a hard part. And the other part of this is just remembering, oh yeah, I've got to take the opposite signs of these numbers. Well, I could show you the original method that we've done before, if you prefer that too. So y equals mx plus b, that's our slope-intercept equation. Alright, we need to plug in our givens. We've been given a y value, an m value, and an x value, so you need to plug those in. You do not change the signs though on these because there's no negatives in front of our variables. So our y is 3, our slope is -1, the x value is -1 as well, plus b. And I guess the hardest part of using this formula is remembering to use parentheses for the x value. You don't want to make it look like it's an 11. Of course, two negatives together won't look like 11 here. And then the next step is you're solving for b, so you're getting it by itself. So you first have to multiply m and x together. -1 times the -1 is a +1. Bring that 1 to the other side of the equation as a -1 and combine like terms. That means your b is equal to... A key concept of perpendicular lines are if two non-vertical lines are perpendicular if the product of their slope is -1. The two numbers whose product is -1 is called opposite reciprocals. A vertical line and a horizontal line are also perpendicular. If the slope of the line is 2, what is the slope of the line of a line that's perpendicular to that 2? Well, you'd have to find the opposite inverse of 2. So if the slope of line 1 is equal to 2, then the slope of line 2, which would be perpendicular to it, has to be the opposite sign, so a negative, because this one's positive. If 2 is the same thing as 2 over 1, if you flip it, you get 1 over 2. So the perpendicular line's slope would be -1/2. D. So to give you an example, if you are given a question, a line passes through the point 1, 8 and is perpendicular to the graph of the equation y is equal to 2x plus 1, what is an equation that represents the line, the slope of the line that's perpendicular? Well, let's first find out the slope of the perpendicular line. First of all, the line that they give you has a slope of 2. Or the same thing as 2 over 1. The perpendicular line has to have the opposite inverse, because if you multiply 2 times -1, you get -2, and 2 times 1 again is just 2, which equals -1. So their opposite reciprocal would have to be -1 over 2. The slope of the perpendicular line then is at -1/2. If we use the point slope equation, y minus y1 is equal to the slope times the quantity x minus x1, you can fill in now the new slope. So y minus, or the opposite of, I should say, the opposite of the y point. Well, our y point is, sorry, my pen kind of covered it up there. The y value is 8, so the opposite of +8 is -8, is equal to the slope. We need to use our new slope, the -1/2, times the quantity, x, and opposite our x point. So our x point is +1, so we would write -1. If it was a -1, we would write +1. Of course, in all these lessons, they will ask you to finally write the equation in slope-intercept form. So you will need to multiply your fraction to the coefficient of x and to the constant of -1. So y minus 8 is the same thing as -1/2 x times -1/2 times -1. Don't make this harder than it is. 1 times anything is just itself. A negative times a negative equals a positive, so it's positive 1/2. The last step you would need to do then is to move that negative 8 to the other side of the equation as a plus 8. Now this is where your rules of fractions are going to help, because you're going to have to add that 1/2 plus 8. So 1/2 plus 8, they do not have common denominators, so you can't just add them as is. We can put that 8 over 1, and then we look at this, and our denominators are 2 and 1. They're still not the same, so we can't add our fractions yet together. There's 2 methods of doing this. You can use the crisscross method of addition, or you can use the CD method. I'm going to demonstrate crisscross at this time just because our fractions are already horizontal from each other. So with crisscross, you will crisscross the denominator and multiply it to the numerator. 1 times 1 is 1. 2 times 8 is 16. And then applesauce. Crisscross applesauce. You multiply the 2 denominators together, and that becomes the new denominators for both fractions. 2 times 1 is 2, so those become the denominators of both. Now we have 2 fractions who have common denominators, and you can just add their numerators together. 1 plus 16 is 17, and the denominator stays the same, 17. If this was a little fast for you, or you know you need more help with adding fractions, then please see an instructor to get some more practice problems. So that when we add those 2 fractions together, we had 17 over 2. That's what all that is equal to. So our final equation is y is equal to negative 1/2 x plus 17 over 2. Don't be discouraged if your slope is a fraction. It won't happen all the time. I know you might want to give up and oh, I'm just going to guess that problem. You could do it. I know you can. Alright, so let me demonstrate a couple of problems with these. First of all, is look to see what you're given. If you're given a perpendicular line or a parallel line. If it's perpendicular, again, the only thing that matters is the slope. Even in focus question 4, the only thing that matters is the slope. We don't really care about anything else about the problem. If the slope of the perpendicular line is negative 1/3, then the slope of our line the new line that would be perpendicular to this one, so our slope 2, has to be the opposite inverse. Well, if we have a negative 1/3, then the opposite inverse would be 3 over 1, or just 3, positive. Now we know a slope and we have an x and y value, so we can plug it into our point-slope equation, or you can just start right from the beginning with the slope-intercept equation. I'm going to go ahead and demonstrate point-slope just because that's using that as part of this lesson. So our x value and our y value is located here, but remember in the point-slope equation we have to use the opposite, that's what that negative is there. We have to use the opposite signs. Is equal to, try that again. Y opposite of y1, so y1 is 5, so you'd write negative 5, is equal to the slope of the line that we want, so 3x opposite your x, so negative 2. Use your distributive property, y minus 5 is equal to 3x minus 6, and then move the 5 to the other side by adding 5. Sure, your final equation should be y is equal to, because those 5's cancel out, 3x minus 1. Alright, let's try it for focus question number 4. Y opposite your y term, so plus 3, is equal to the slope that you want. If our slope of the perpendicular line is negative 1/2, we need a positive 2 over 1, or just 2, times the quantity x opposite our x, so negative 1. Use your distributive property, y plus 3 is equal to 2x minus 2, and move the 3 to the other side of the equation. So y is equal to 2x minus 5. On the next page there are 6 group practice problems which we'll use as guided practice problems. Go ahead and push pause, get as far as you can on each one of these problems, and then press play to see your answers, or if you get stuck, to see what the next step is. I'm going to be doing 2 problems at a time, the ones that are horizontal from each other. So the first 2 problems I'm going to do is problem number 1 and problem number 4. Go ahead and push pause, get as far as you can on them, and then push play. Okay, let's take a look at the first answer. The question asks for you to write an equation of a line through a parallel line, or one that's parallel to it, through a point of 2, 2. So the slope of the line that we need also has the same slope as the parallel line, or m is equal to 3/2. Write down the point slope formula and make sure to reverse the signs of your x and y value in the equation. Then I distributed 3/2 times x, that's, with the coefficient of 1, so it's still 3/2, and then 3/2 times -2, which is a negative, and then over here I multiplied my 3/2 times 2. I had to put a 1 underneath the 2 because you can't multiply a fraction to a whole number, but you can change any whole number to a fraction by simply putting a 1 under it. With multiplication, this is not crisscross, this is just multiply straight across. 3 times 2 is 6, 2 times 1 is 2, and then I reduced the 6 over 2 to 3. Finally, I had to combine my like terms, or move that constant of that -2 over as a +2 to the other side, and I finally got my slope-intercept form of the equation of y equals 3/2 x minus 1. I rewrote that multiplication part of the problem over a little bit so that I had enough room to solve the second problem, or problem number 4. So if you haven't started working on problem 4, go ahead and push pause. Otherwise, continue listening or push play when you're ready. Right. This time, problem 4 asks for you to write an equation that is perpendicular to the line that's given. Again, we only care about the slope of that equation, but because it's perpendicular, we need the opposite inverse. So the line's slope of the line we're trying to write has a slope of +8, because if you flip 1 over 8, you get 8 over 1, which is the same thing as 8, and we change the sign to +8. Now we have a slope, an x, and a y value. So y opposite the y term, so -3, is equal to the slope of the equation that we want, the +8, times x opposite our x term, -2. We distribute the 8, so y minus 3 equals 8x minus 16, and carry our 3 over as +3. So our final equation is y is equal to 8x minus 13. Could you have used the slope-intercept form equation from the beginning instead of the point-slope equation? Yes, you could have. Let me switch colors here just so I can demonstrate that, because maybe you've been doing the problems that way, and that's perfectly fine. You use whichever formula works best for you. So if I use this slope-intercept form equation, I would use y equals mx plus b. I'd substitute the m, the x, and the y into the equation that I know. I do not have to change the signs, though. So y is equal to 3, m is equal to 8, times the x value is 2, plus b, and then you'd have to solve for b. You multiply the 8 times the 2, so 3 equals 16 plus b. Then subtract the 16 from both sides. So b is equal to -13. And then you substitute that b value in and the slope that you had at the very beginning of the problem into the equation. Y is equal to m, that's that 8x plus or minus b, so to be a -13. You can see we still get the same answers. That right there looks like a lot of steps. I don't know, it's a preference. It really is a preference. So you can use either equation, the slope-intercept form equation or the point-slope form equation. Alright, hopefully you've attempted problem number 2 now. If not, you can push pause and then push play when you're ready. Question number 2, we are trying to write an equation that's parallel to the line given, so therefore our slope must stay the same. Now that we know the slope we want, our x and y value, plug it in. I'm going to use the point-slope equation in purple, and I might do the slope-intercept form equation in blue, just in case you've done it the other way. Point-slope. Alright, y opposite your y term, so -1, is equal to your slope of 4 times x opposite your x, so -2. Distribute the 4, so y minus 1 is equal to 4x minus 8. And then add your 1 to both sides of the equation. Y is equal to then 4x minus 7. That's your final answer. If you chose to use slope-intercept form from beginning to end, y equals mx plus b. Substitute your y value without the sign reverse, so positive 1 is equal to 4 times your x value of 2 plus b. Solve for b, so 4 plus 2 is 8. Bring that to the other side as a -8. So b is equal to -7. And then plug your b and your slope into the slope-intercept form equation. Y is equal to 4x minus 7. When you're ready for problem 5, push play. Problem number 5 asks you to write a line that's perpendicular to the line that's given. So the perpendicular slope would be m is equal to opposite sign, so a positive, and then flip that fraction around, 3 over 1 or just 3. Using the point slope form, y is opposite the y given is equal to the slope times x opposite the x given. Distribute, so y minus 4 is equal to 3x minus 3, don't forget that sign there, and then add 4 to both sides. So y is equal to 3x plus 1. If you use the slope-intercept form, y equals mx plus b, your y value is 4, slope is still 3 times x of 1 plus b. You're solving for b, so you have to multiply your m and x together to get 3, and then bring it over to the other side as a -3. Combine your like terms, and I got 1 that time. Let me see where I made my mistake. Oh, I didn't make a mistake. I was looking at the other problem for some reason. Yeah, it still should be 1. There's our b value. 1 is the same thing. So y is equal to 3x plus 1. Got the same answer no matter which formula you start with. Last 2 problems. If you need to push play, why don't you go ahead and complete both problems to its fullest, and then push play to check your work. Alright, problem 3. It asks for a parallel line, so the slope is the same, 1/2, and that's all we care about. If you need to, cross off the rest so you're not worried about anything else. So with a slope of 1/2, an x of 2, and a y of 3, plug it in. If you use the point slope equation, y opposite your y is equal to slope times x opposite your x, so -2. Distribute that 1/2, y minus 3 is equal to 1/2 x. Ooh, 1/2 times, or a positive times a negative is a negative, but 1/2 times 2 is the same thing as 2 over 2, which is equal to 1. Add 3 to both sides. So y is equal to 1/2 x plus 2. If you use the y equals mx plus b formula, y is 3, your m is still 1/2, times x, which is 2, plus b. Solve for your b, so you have to multiply those two together. We just showed that right here, so we know that that is equal to 1. Bring that to the other side as a -1. And what did I do here? Oh, because one of them was negative. That was a -2, correct? Or it was a -1? It was -2. There we go. That was a negative. So this was a negative. That means that would have been a positive. So you would have got, let me see. What am I doing here? Hold on. All right, I'm confusing myself because why? I took a shortcut by not showing that y equals mx plus b equation. So let me start that over again. Y is equal to mx plus b, where y is equal to 3, m is equal to 1/2, x is equal to 2. Yeah, so there we have, oops, and that's a plus b. Multiply those two together. We do not have the signs. I was getting confused with that sign change from the previous problem, so that equals 1. Bring that 1 over to the other side as a -1. So 3 minus 1 is 2. That's our b value. B is equal to 2. And you can plug that back into the original equation. Y is equal to 1/2 x plus 2. It's the same answer. I'm going to have to erase it though. We have that answer over here still. Oops, didn't mean to erase that. We still have the answer over here, the 1/2 plus 2, so if you need to check it, but I'm going to have to erase it over here to give us room for problem number 6. Last one, and this will be your final lesson of this unit and in this course. The rest is all review. Okay, this time we are trying to write an equation that's perpendicular to the line that they give you. The slope of the line they give you is -1/7, so our perpendicular line has to have a slope of +7. Using the point slope equation, y opposite your y, so that would be a +5, is equal to your slope of 7, x opposite the x value, so that would be a +1. Distribute the 7, y plus 5 is equal to 7x plus 7, and then subtract the 5. Y is equal to 7x plus 2. Even if you use the slope-intercept form, you should get the same equation. Alright, that concludes the lesson of this unit, of this course. Good luck, and you just have review practices after this. You can do the online review as well to get ready for your Unit 3 test and then your final exam.